Hello, today we are going to start our next lecture which is known as the conventional surface engineering. So, as I told into the last lecture that there are two methods by which we can do the surface engineering applications or maybe surface engineering process. One is called the conventional, another one is called the non-conventional. So, now in this particular slide we are going to discuss about the conventional surface engineering. So, first we will start that what is conventional surface engineering. Actually the conventional surface engineering is the traditional process or maybe the you can say some kind of old method which is coming since long back and nowadays also we are following. Next we will discuss about the non-conventional surface engineering too, which we will do by some kind of using some kind of sophisticated machines, some kind of sophisticated techniques which we can't adapt as easily. But in this particular chapter we are going to deal with the conventional surface engineering process. So, before going to start that what is the process, what is the definitions of that particular process or maybe how many types are there, before going to start first we have to know that why we are doing the conventional surface engineering process. So, conventional surface engineering process generally we are doing to removal of some dust particles or maybe some kind of contaminants or maybe some kind of impurities from the metal surface. Again we can add certain kind of materials, that means by adding some kind of materials in terms of coating or maybe in terms of any kind of implantations or maybe in terms of any kind of layer, we can add certain materials onto the surface of the base metals. Then we can do the modifications of the ferrous and non-ferrous components. As we know, rusting, which is the biggest problem for any iron material. So, that iron material if I keep longer time into the environment, that can react with the environmental oxygen and iron oxide can be formed, which is totally a different phase than the iron and which we can't use for longer time and that is a wastage of the material. So, by these techniques, by conventional surface engineering we can make the anti-corrosion materials or maybe anti-oxidation materials or maybe top of that we can do certain kind of layers so that the material can be shaped. Next, modifications using liquid or molten bath. Simply in the next subsequent slide we will see all these methods into brief or maybe we will go into that depth. So, here simply we can dip our material into some bath or maybe some kind of liquid medium and after that we can take out the sample so that a coating of layer can be formed on that particular material by which we can do the surface engineering. And the last one is called the modification using gaseous medium. So, simply we are putting our material into some gaseous mediums by which that gas can react at the outer surface of that particular materials and it can form any kind of coatings or maybe layers or maybe barriers so that the material will not directly come into the contact with the environment. So, by doing this kind of techniques we can do the conventional surface engineering. First we have to know what are the methods by which we can remove the unwanted materials on the surface of any material. So, there are several methods. So, first surface engineering by removal of material, it is divided into 6 basic types. First one is known as the cleaning, then pickling, etching, grinding, polishing and the buffing. Next slide we will go each into detail. So, first one is known as the cleaning. So, from the name itself you can understand that we have to clean the material so that its outer surface can be cleaned or maybe any particles has been stick with the outer surface of that particular material or maybe can attach or maybe can deposit onto that substrate or maybe that material surface. Simply by cleaning process we can remove those unwanted particles or maybe the impurities or maybe any kind of hazardous materials too. So, cleaning, there are generally 5 categories of cleaning process are there. First one is called the alkaline cleaning. So, simple we are putting that material into some alkaline solutions so that there is some kind of reaction with base materials. So what will happen, due to the chemical reaction between base solutions and substrate, the surface of substrate will be modified. Next, emulsion cleaning. So we can dip the material into some oil and water medium so that the outer surface can be cleaned. Next is called the solvent cleaning, hot vapors of chlorinated or fluorinated solvents. So first we are creating some kind of vaporizations of some kind of chlorine or maybe the fluorine solvents, which can react with the outer surface of that particular material and it can clean the outer surface. Next is called the acid cleaning. So generally this type of cleaning, we are, the basic example is that generally we are doing this kind of cleanings for our jewelry materials. So suppose our any kind of jewelry materials like gold or maybe some kind of made by brass or something like that, if there is some attack, after certain time its glitterness is getting reduced and its material properties is getting deteriorated, and due to which the material outer surface is getting black. So by just dipping those materials into some acids, we can clean the outer surface of that particular material. And the last one is called the ultrasonic cleaning, aqueous alkaline solutions with high frequency vibrations from 20 to 45 kilohertz. Here we are having some kind of chemical solutions, but simply we dip our material into that chemical solutions, maybe it will not react or maybe it will not be cleaned. Then what we have to do, we have to put the horn of that ultrasonic bath or maybe that ultrasonic sonicator into that solutions, and we have to agitate those solutions, by which the chemical reaction will start in between the chemical solutions and the outer surface of that particular material, by which we can do the cleaning process. Next we will discuss about the mechanical cleaning process. So till now we are discussing about the chemical cleaning process, by which we are using certain kind of chemical materials and we are doing the allowing the material to do some chemical reactions with the solvent itself, and then the reactions is taking place. But in this particular slide we are going to discuss about the mechanical cleaning. That means we are applying any kind of energy in terms of pressure or maybe the load or maybe the any kind of erosions or maybe any kind of abrasions onto the material surface, that means by which the material outer surface is getting cleaned. So what are those? First one is called the blast finishings. So blast finishings is, there are several types. It is called the sand blasting, hard abrasives mainly alumina and silicon carbide, and soft media like nylon beads. So it depends upon which type of materials you are going to clean. If your material will be softer, then you have to take the soft abrasive particles, and if your materials will be harder, then you have to go for the harder abrasive particles. What you have to do? You are having a container over there, in through you are putting your abrasive particles, then one side you are having the compressor which is generating the compressed air, then your abrasive particles is mixing with the air, and then with a high velocity you are throwing that particle onto your material surface, by which a rubbing or maybe friction is taking place, by which your material outer surface is getting cleaned. That is known as the blasting. Now what type of abrasive you are going to take depends upon that, there is several nomenclature. If you are going to take the sand as a abrasive particle, it is known as a sand blasting. If you are going to take the alumina or silicon carbide, these all are known as the hard abrasives, that is why it is called the hard blasting. Next is called the shot pinning. If you remember that in my last lecture I have already discussed about the shot pinning. Shot pinning is nothing that you are going to use certain balls which is made by some ceramics or maybe some kind of hard particles, then from a particular height you are relieving those balls and directly those balls is coming to the surface, and while it is coming it is gaining some kinetic energy. Due to that kinetic energy, it is getting a depressions or maybe giving a depressions onto your material surface. So material surface is going to be modified, or maybe there is some kind of impurities or some kind of dust particles which maybe can be vanished at the impact of that particular balls on that particular surface. and third one is called the mass finishing. Mass finishing is nothing but the simple grinding process. So, here we are having some kind of grinding wheels or maybe some kind of finishing process like hunning, lapping, grinding. Then there are so many unconventional methods are also there, by which you can put your material onto some abrasive particles and then abrasive particles which rub its surface, and you can do the surface engineering by these methods. So, that is why it is known as the mechanical cleaning process. Next we will start with the pickling process. So, from the name itself you can understand that pickling process is something like that we are going to put certain material on top of the surface, then either it will dry or maybe it can be doing some kind of chemical reactions. After that we have to wash that surface, and due to that your surface modifications can be done. It is also one type of things that when our face is getting dirty, then we can use some certain kind of face wash or maybe some kind of soaps. So, first we are cleaning that face, then while we are washing that soap particularly, it is taking out the dust particles with it. So, in simple versions, that is none other than the pickling process. So, here it is a metal surface treatment used to remove impurities, generally stains, inorganic contaminants, rust, aluminum alloys, oxide layers, etc. A solution called pickle liquor, strong acids, is used to remove the surface impurities. So, here this pickle liquor is acting as a soap. So, just it will cleanse your material surface. Pickling pastes are commonly used to treat selected areas such as welds. So, from this particular figure you can understand that we have done certain kind of welding, then after that we are putting that pickling liquor which is acting as some solvent over there, then after certain time we will wash it, and whatever the dust particles or maybe rusting has been formed, it will come out with your pickling liquor. Here this is also the another process generally which we are seeing as an industrial process, or maybe generally we are adopting this process when we are doing the continuous manufacturing of some parts of in industry. So, here this is the entry sections where we are putting our materials, then that materials is going through acid tanks which is nothing but the pickle liquor, then through that it is the time can be controlled by us, that how much time it will be in the acid treatment, then again it will come to the some rinsing sections where you are washing those materials so that pickle liquor can get out or maybe can be removed, then it is going to through the exit sections, and exit sections you can put certain entry like that it will wash, then it will wipe, or maybe it will clean, then it will test, and if it is okay then it can go for the assembly purpose. There is certain limitations of that this particular techniques too. What are these? One is called the corrosiveness and not applicable to all steels, because you are using certain kind of acids. If your material is soft or maybe it does not have that acid inertness, maybe it can react with the pickling liquor. Alternative to pickling, electropolishing, where metal removal is achieved with bright, smooth and highly corrosion resistance finish. So, simply there will be some kind of chemical reactions in between the potential difference, which I will come into the next slide. So, there you can do certain kind of chemical reactions by which your rusting or maybe dust particle can directly come out from your base metal. Next method is called the etching. Etching is nothing, if you want to remember, I can tell you one example, that etching is nothing, just make some scratch onto the metal surface. So, simple, I am having that surface and I want to scratch it like this. This is also one kind of etching process. So, by etching also we can clean the material surface. So, there are several types of etching. One is called the wet etching, then dry etching, non-toxic etching and photo etching. So, one by one we will go into the detail. What is called the wet etching? First one, it is called the chemical process, because wet you are using some kind of liquid or maybe solvent which is into the liquid form. So, that is why it is called the wet etching. So, it is a chemical process, isotropic process that uses liquid chemicals or etchants to remove materials from a wafer, cheaper than dry etching, but very difficult to start and stop, because unless and until reaction will be finished you can't stop this, and you have to put the etchant onto your surface or by any brush or maybe by any other means, or maybe you can dip your materials into some etchant, so that the chemical reactions will be taking place. Next one is called the dry etching. From the name itself you can understand that we are not going to put our material into some liquid form or maybe into some wet gel or something like. So, here we are doing it into the dry medium. So, physical or chemical process or physico-chemical process. Anisotropic techniques include plasma enhanced, reactive ion, etc. Removal of material by exposing the material to a bombardment of ions. So, here just we are using certain kind of electron gun or maybe some kind of bombardment of ion implantation type of things, where the ion is directly coming, it is giving or maybe getting a reactions onto the surface of that particular material. By that some material, some portions of the material can be go out, so that you are getting a virgin surface or maybe the newer surface. Next is called the non-toxic etching. So, generally ferric chloride used as etching solutions and does not produce a corrosive gas as acids do. That because nowadays every people is talking about the environmental concerns, that we should not make any kind of gases which will be toxic, which can come to the environment, so that there will be some problem for exhaling and inhaling, and maybe it can cause certain kind of problems to the eyes or maybe our skins. So, the non-toxic etching means when we are doing this kind of reactions, because maximum reactions is exothermic reactions, they are generating certain kind of fumes, gas or maybe some kind of heat. So, whatever the non-toxic case, that it is not creating any kind of toxic gases which is harmful to the operator as well as to the environment itself. Next one is called the photo etching. So, chemical milling process used to fabricate sheet metal components used on any commercially available metal or alloy, mainly aluminum, brass, copper and steel. So, this is also another kind of modified versions of the etching process. Right hand side you can see that there are two types of etching. One is called the dry etching, it is called the vertical sidewells, another one is called the wet etching. So, here you are having the for polysilicon methods, here you are using certain kind of mask over there, so that your etchant is going and it is doing the reactions with the surface of that particular material. Next, there are two types of etching you can done, one is isotropic, another one is called the anisotropic. So, isotropic etches equally in all directions. When you want to do the etching of all surfaces, you have to dip that material into some solutions, so that chemical reactions can be taken place all around. So, that is why it is called the isotropic etching process, and anisotropic etches at different rates in different directions. Then either you have to dip your material only one side, or maybe you can put the coating of that etchant material on a single side, so that you can restrict the reactions in different ways. Next one is called the grinding. So, grinding in a mechanical term is simply, it is called the one kind of finishing methods. So, when we are making any kind of material by casting, forming, the final portions is called the grinding. So, in grinding here generally we are using some kind of abrasive particles which can rub your materials or maybe the surfaces or maybe metal surface or maybe any kind of surface, and by which it can be smooth. So, what is the method? The method is that you have to use certain kind of wheel, generally which is known as the grinding wheel. Then we can attach certain kind of abrasives over there. It depends upon what type of materials you are going to grind. If you are going to grind the softer materials, your abrasive particles will be little bit harder than the softer particles, or maybe your materials will be harder, then you have to go for maybe alumina, silicon carbide, carbonandum or cubic boron nitride. So, these all are the different materials as a abrasive particles you can used. So, it is a material removal and surface generation process used to shape and finish components made of metals and other materials. It is an abrasive machining process that use a grinding wheel as the cutting wheel. It is used to finish workpiece with high surface quality and high accuracy. The precision and surface finish can be up to 10 times better than with either turning or milling operations. Turning and milling also one kind of conventional machining process, like lathe by lathe machines you can do the turning operations. We are having the milling machines by which you can do the milling operations, or maybe by shaper you can do the shaping operations, but these all are the conventional machining process. But when we are talking about the grinding, depending upon the size of the abrasive particles, if it is very smaller, you will get the better surface finish over there. If the particles will be bigger, or maybe the coarse particle you are going to use, then only you can get some kind of rough surface. So, depending upon that, whether you can go for a harder material or maybe you can go for a softer material, you have to choose different types of abrasive particles over there. There are several types of grinding machines are available. One is called the belt grinder, where your belt is acting as a grinding wheel or maybe the grinding medium. Then bench grinder, tool and cutter grinder, surface grinder, cylindrical grinder, jig grinder, gear grinder, die grinder. So, depending upon how you are going to grind your material, how you can hold your material, so that you can place your grind abrasive particles nearer to the material or maybe closer to the material, so that it can grind any complex shapes or maybe any kind of positions where the normal persons can't go or maybe can't reach. So, it depends upon we are having several types of grinding mechanisms. Next one is called the polishing. So, simple term polishing or maybe polishing is nothing that just we are lightly rubbing the material, by which we are enhancing the material properties in terms of maybe its color or maybe shape and size, or maybe whatever is there any rust or maybe oxide formations, we can clean it over there. So, it is not as much as like grinding, because grinding the material removal rate is higher than the polishing. Polishing is a light work. So, by which simply we can rub and we can do it, but your rusting and everything is into the deeper to the material surface, that time we have to go for the grinding, we can't do it by the polishing. So, creates a smooth and shiny surface by rubbing or using a chemical actions. It is the most refined finishing process by removing the finest surface particles. So, as I told already, a few layer only can be removed by this polishing, we can't go for the deeper thickness of that particular material. Glued abrasive particles in the work wheel acts on substrate surface. Polishing improves the strength of restorations, especially in the areas that are under tension. So, there are several types of polishings you can see over here. One is called the flame polishings. So, we are using certain kind of heat by which we are doing the polishing process. Then metal working, which is also divided into 4 parts. One is called the burnishing, tumble finishing, vibratory finishing, soda blasting. So, from this particular figure you can understand that we are using the burnishing over there. So, it is also one kind of coatings. If there is any cracks or small pores, so by burnish we can fill up this area, and so that you can get the smooth surface. Then next is called the tumble finishings, vibratory finishings. By using the vibrations of that particular machines, we are rubbing the outer surface of that material, so that it can be smooth or maybe its affected area can be removed. Next is called the soda blasting. So, the best example is that till in our house or maybe home, our grandmother or maybe grandfather, they used to say that if we are having some gold ornaments or something like that, we are putting it into some soda solutions, then we are little bit heating, so that its glitters can once again it will come back. So, by doing this one also, that is also a polishing method. So, by doing these methods also we can do the surface finishings, or maybe we can remove the any kind of acids or maybe toxicity on the materials too. Next one is called the vapor polishings, by which we are creating the polishing by vapor. then chemical mechanical polishings, and last one is called the woodworking. It is also divided into two parts, one is called the French polishings and called the wood finishings. So, wood finishings means we are using certain kind of oils or maybe certain kind of emulsions by which we are going to use the polishing methods. Next one is called the buffing. So, buffing is also like a polishing methods in which abrasive grains are not glued on the wheel. Here one wheel is there and surface is there, just we are putting the abrasive particles in between these two. So, the abrasive particles are free here. So, by these methods we can do the surface engineering process, and that is known as the buffing. So, this process uses a tool, that is rotary buffers or orbital buffers. Here this is the tool, it is rotating and there is having some workpiece, and in between these two we are putting the abrasive particles as a free. So, that is known as the buffing process. So, polishing process is often a preparations for the buffing process, as in polishing the abrasive particles must be periodically changed or maybe replenished. Why? Because your wheel is giving a pressure onto your metal due to this gravity or maybe weight. So, whatever the abrasive particles I am using over here, with constant rubbing and a normal load is acting always, it will become means it will break into small pieces. So, after certain time all the projection area will be blunt. So, what we have to do? We have to put the newer particle so that we can get the newer projection area which can rub easily onto the material surface. So, there are two types of buffing, one is called the cut buffing, another one is called the color buffing. So, cut buffing, it involves cutting down the surface of brass, copper and other metals and coloring it at the same time. And what is called the color buffing? It gives the metal finish as a mirror like shine using polishes as known as the rouges. So, it depends upon what type of particles you are going to use, how much load you are giving, so that you can get the shiny surface or maybe you can get the dull surface too. Next is called the liquid treatments by additions of materials. So, here we are doing this surface engineering by additions of any materials. So, first one is called the liquid bath hot dipping. So, it is a galvanizing process of coating iron on steel with a layer of zinc by immersing the metal in a bath of molten zinc. So, as we know, the zinc melting temperature is around 440 to 450 degrees centigrade. So, we are having one bath of molten zinc. Simply we are taking our material, first we are cleaning it, then we are dipping this into the zinc solvent, then after certain time we are taking out the sample, we are allowing that sample to be cooled, then when it will be cooled we are using it for our purposes. So, that is why it is called the liquid bath hot dipping process. What are the advantages? First one is called the galvanized steels is suitable for high temperature applications up to 200 degrees centigrade. This type of coating is relatively easier, cheaper than other galvanic paint coating. So, from this particular figure you can understand, first we are doing the degreasing, then rinsing, that means any grease or maybe oily surface is attached with the surface. If we dip that sample into some solutions, maybe the zinc will not stick with the material. So, first we have to clean the materials outer surface so that the adhesions will be more, then we can dip this into the zinc solutions, then after that we can do the drying, then again we can put into some solutions, zinc solutions. So, several times either if you want to increase the coating thickness, we can dip our material several times in the zinc bath or maybe a single time, then after that you have to do the cooling operations and inspections whether the coating is uniform or not. Next one is called the electro depositions or maybe the plating. So, from the name itself you can understand that we are having one cathode and anode terminals, then we are putting those materials into some electrolyte, then we are using some voltage potential difference over there, then due to that the one material it is releasing some ions and that ions is coming into the molecules form and then that molecule is depositing to the another material. So, here from this particular figure you can understand that we are using some copper as a anode materials and another material on which we are going to use the copper coating over there. So, we are putting that material into the cathode, then we are through battery we are generating the high potential difference in between these two, so that this copper ion it is going and it is depositing on the outer surface of your coating material. So, electroplating is often also called as electrodepositions, a short versions of electrolytic depositions. It is a process that uses electrical current to reduce cations of a desired material from a solutions and coat the material as a thin film onto a conductive substrate. There are some advantages too. Uniform and compact deposits can be synthesized because you can control the time, you can by controlling the time you can increase or decrease the thickness of that particular coating. Also high deposition rates are obtained if you go for a longer time. Next, surface modifications of ferrous and non-ferrous compounds. Here we can see certain kind of unconventional methods or maybe conventional methods. Under this, one is called the aluminizing. From the name itself you can understand that we are going to do the coating of aluminum onto your material into some environment. So, surface of metallic component is coated with a layer of aluminum. Steel and its alloys are most common metals that are aluminized for commercial applications. Enhancement in corrosion resistance in hazardous atmospheres, durability and a high yield strength is highly corrosive environments. So, we are doing a coating of aluminum onto the material surface. Next one is called the calorizing. Calorizing also one kind of aluminum coating, but here also we are adding some kind of base materials on which you are going to do the coating. So, it is a formations of surface alloy composed of aluminum and the metal being calorized. Calorizing is performed in a powder mixture, generally 50% aluminum and 49% alumina and 1% ammonium chloride or 99% ferroaluminium and 1% ammonium chloride mixture. Such an alloy of aluminum and the base ferrous and non-ferrous metal protect the metal against the effects of heat or oxygen. Next is called the cyaniding. Cyaniding means we are putting our material into some cyanide, means potassium cyanide or maybe the sodium cyanide environment, by which that CN group, generally that is known as the cyanide group, that can attach with the material outer surface and can do some kind of coatings or maybe the surface modifications. So, it is a case hardening process mainly used on low carbon steels. This part is heated around 871 to 954 degree centigrade in a sodium cyanide potassium cyanide bath, followed by quenching and rinsing in water or oil to remove any residual cyanide. Produce a thin hard cells which is harder than one produced by carburizing. Advantages: less opportunity of distortion due to less process time. Disadvantages: cyanide salts are poisonous. We know that Madame Curie, she has invented the cyanide as a poison and this is very poisonous to our body also. Next is called the liquid carburizing. So, it is a heat treatment process used for case hardening steel or iron parts. Diffusions of carbon and nitrogen or carbon alone into the metal. So, here the first case when we are talking about the carburizing, we are putting the material into some carbon environment, but here that carbon environment into the liquid stage. So, we have to dip our material into that liquid carbon solution, carbon dioxide solutions, and we can do the liquid carburizing. Greater case depth over carbon nitriding, less distortions and better impact strength, applicable in high strength and wear applications. There are certain limitations also, expensive and higher working temperature is required. So, that is why generally these methods we are using into the industrial purpose. Next one is called the nitriding. Probably in the last slides also I have discussed about the nitriding, but that time only I said only one line that we are doing the modifications into some nitrogen atmosphere. How we are creating the nitrogen atmosphere? Either we are using some kind of ammonia gases on which we are keeping our the materials, then the nitrogen can act on the material surface and do the surface engineering. So, diffusions of nitrogen into the metal to create a case hardened surface. In gas nitriding, the donor is a nitrogen rich gas ammonia and also called the ammonia nitriding. Ammonia dissociates into nitrogen and hydrogen into heated workpiece and diffuses into the surface of workpiece and creates a nitride layer over there. Advantages: precise control of chemical potential of nitrogen, relatively low equipment cost. Disadvantage: ammonia can be harmful when inhaled in large quantities. So, we have to take that precautions too. So, here this is the material, this is the total schematic diagram where the gas is going inside and then another side the gas is coming out. You are having two terminals, one is called the cathode and anode, then your ammonia is dividing into two parts, one is called the nitrogen, another one is called the hydrogen. Hydrogen is coming out and nitrogen, it is creating a reaction with the surface and it is forming the nitride layer on top of the surface. Then next one is called the carbonitriding, modified carburizing process and mostly done at lower temperature than carburizing. Hardness of metal increases and thereby reduction in wear, diffusion of carbon and nitrogen into the workpiece. So, this is also one kind of, we can say, the modified versions of the nitriding process. So, from this you can understand that for carburizing we are use the temperature around 950 degrees centigrade. For carbonitriding we are using the temperature around 850 degrees centigrade, and for nitriding we are going the temperature up to 530 degrees centigrade. So, it depends upon the what is the melting temperature of that particular material, and if your melting temperature is low then you can go for the nitriding or maybe carbonitriding. If your melting temperature of your materials is high then you can go for the carburizing too. Advantages: increase fatigue and impact strength, carbonitride layers increases the residual compressive stress in the case, produces higher hardness than a carburized case. Then these all are the applications generally by which we are doing the surface engineering. Here I have given a very minimum examples, but there are n number of examples are present over there. So, first one is called the automotive applications, aerospace applications, biomedical applications, machine tools, textile industry, electronic device, we can do the surface engineering. So, here we have seen that mobile nowadays we are making, which is the water resistance. That means we can dip the mobile into some water and the water will not interact with the material by which the mobile has been prepared. Next slide we can summarize our whole lecture. So, first is called the conventional surface engineering belongs to traditional surface treatment process. Surface treatments protect the workpiece from corrosions, fatigue, wear and other environmental damage. Simply from the outer attack, the surface engineering will prevent our material properties. Surface engineering assists to increase the durability and reliability of the material. That means it will increase the life of your particular material. Suitability of a particular surface treatments mainly depends upon the targeted applications. So, it depends upon the applications by which you can adapt. There are several surface engineering process I have explained. So, it depends upon which type of applications you are going to do, and based on that you have to choose different types of surface engineering process. Thank you.